Find the probability that some data value is between 10 and 22. It was very similar to what I did on the warm-up. I'm going to go over two more that I similarly did on the warm-up, and we're done. Okay? So 10 and 22 do not fall nice and neatly on the standard deviation. I could see that my mean is 8, standard deviation. What is my standard deviation here?
10.
Gracias. Okay, we're getting that down, very nice. So let's see, where does 10 fall? 10 falls a little bit above the mean. Here's 10. And then 22 is also above the mean, a little bit past the first standard deviation. I'll put it about right here. Here's 22. So I'm interested in now, watch this. I'm interested in the yellow, just like warm-up. Think about warm-up. This is very similar to warm-up, almost a replica. I'm interested in that. What's the probability that a randomly selected data value lies in that yellow region? You found it already? That was impressive. Well, I like that strategy. No, because look at the curve gets higher, so you have a greater proportion. That would work if everything was equal. I like how you're thinking. But the more if you start shifting stuff, you have greater volumes of data. That makes sense. It's not an equal volume. So what we're going to do is do the data, the z-scores, just like warm up. I must say, you guys are a peculiar Math 3 class. I typically get more questions. You guys don't really ask too many questions, so I want to invite you and encourage you to ask me questions while I'm lecturing. If there's something that's still a little iffy or questionable, that's one of the main ways you learn mathematics is through questioning. So if I'm going too fast or you have questions, please stop me and let's get to the bottom of any misunderstanding. Z-score is whatever the data value is minus the mean divided by sigma. So I'm going to take the z-score of the lower 10. Let's go 10 minus mean is 8. Standard deviation is 10. Nice. Ten minus 8 is 2 if my coffee is kicked in. 2 divided by 10, I want to say is 2/10, 0.2. So 0.2. Z-score of 0.2, which makes sense. 10 is not even a standard deviation above 8, the mean. It's 2/10 of a standard deviation above. Not even one above. So that z-score makes sense. Now let's figure out what percent is all this data in black. With the z-score calculator. So backspace that, put 0.2. It's not hard stuff, you guys. So below it is going to be 58% of the data in black. So all this in black is 58% of the data. Now let's find the z-score of 22 and figure out what's the yellow and the black below the 22. And then subtract them and we're rocking and rolling. So 22. So z-score of 22. That's going to be 22 minus 8 divided by 10. 22 minus 8, I want to say is 12. No, 14. Good looking up. 1.4, which makes sense because 22 is 1 4/10 above the mean. 1.4 standard deviations above the mean. Let me go to my z-score calculator. 1.4. And we're rocking and rolling, right? 1.4. %92 is below that. It's a lot. In other words, the yellow plus the black all together is 92%. Where's 96? What did I say? 92. The yellow plus the black data is 92. I'm only interested in the yellow. Rojas, what would I do?
Divided by 2.
Close.
Oh.
So look at yellow plus the black is 92%. Black is 58%, but I'm only interested in the yellow. Keep that at what I do. So I'll take the 92, which is the yellow and the black, subtract the black, and I'll only have the yellow. So 92 minus 58. 92 minus 58. Somebody help. 34%. So there's a 34% probability that a data value will be in that yellow area. Fonseca, like this. What's the matter, Fonseca? Is it going to be different?
I said I thought.
Oh, I'm sorry.
You said when it shifts over the amounts change.
And it didn't change?
No.
You're lying.
34%.
Hold on. 34% probability. Probability. Okay. What do you think, Martinez? Iffy still? Sorta, kinda? What do you think?
I'm getting the name of it now.
Okay. I'm looking at you guys and I'm getting the sense that you guys get this now. I'm not gonna do this